Find the Laplace transform using the definition. We know that Laplace of any function, let's say f, is a function of t. This will be defined by the definite integral, so 0 to infinity, this kernel e to the negative st, and the function whatever that, and dt. Okay, and when we evaluate, this will be a function of s variable, this. So using that formula, here we got Laplace of 2t plus 5. That is just this improper integral 0 through infinity of e to the negative st, that's the kernel, times this function 2t plus 5 dt. Now we need to evaluate this improper integral. So it's a product of two functions, so we need to use the method of integration by parts, IBP, integration by parts. But we might have to write down this limit because we cannot work on this infinite domain. So limit, let's make b going to infinity of 0 to b. And when we have an algebraic function, that will be used. So let me write 2t plus 5 first times e to the negative st dt. You know, when we do integration by parts, okay, that's the Eilate rule. So inverse functions, logarithmic functions, algebraic functions, trig functions, exponential. So in this question we got algebraic and exponential, so this comes first. So this is our u, and the remaining is dv for the integration by parts. So here let u be 2t plus 5 and dv be e to the negative st dt. Then du integrate this 2 with respect to t, integrate with respect to t, we get v equals exponential function itself divided by this negative s. So then u dv is uv minus integral v du. So this is same as limit b going to infinity of uv. So 2t plus 5 times e to the negative st over negative s, and it's going from 0 to b. Okay, 0 to b. In fact, this is for t. Okay, if you want to specify that, uv minus integral, that's 0 to b, v du. We multiply these two here is negative, so that makes this positive, and we have 2 e to the negative st all over s, this negative I put outside, dt. Let's evaluate this. So this is limit b going to infinity of, here we need to evaluate upper limit minus lower limit. So replace t by b. So this is 2b plus 5 times e to the negative sb over negative s, that's the upper limit part, minus lower limit means t equals 0. So this is 0, so just 5 times e to the, oh, t is 0, so e raised to 0, that's 1. So this will be just 1 over negative s, negative, let's make positive, yes. That's just from this first part. Plus, now we can pull 2 over s outside, because this integral is for with respect to t. So 2 over s outside, that leaves e to the negative st, and the integral of e to the negative st is itself divided by negative s, because we are doing with respect to t, and we have limits from 0 to b. Okay, here this limit is for everything, by the way. For now we can apply this for the first part, and we can apply this for after we plug this in. Okay, so b going to infinity, here is e to the negative if this s is positive and this is infinity, e to the negative infinity, and e to the negative infinity is 0. In fact, this will be infinity, but this exponential function beats the race, though this is an indeterminate form, but this one goes to 0 faster than this. So if you do L'Hopital's rule, you can work on that. Okay, so this limit will be 0 if this s is positive, because negative infinity, we want to make e to the negative infinity, that's in fact 0. And okay, I'm talking about in terms of limits, by the way. So this one will be 0. So let me write that. So this will be 0 when this s is positive. Okay, when this is positive, b is going to infinity, means everything positive, negative infinity is 0. And here nothing. So let me write next step. Then we get this limit b going to infinity. Just for the second part, this is 5 times 1, 5 over s plus 2s and s is square, so negative. So this is, we can write down negative 2 over s is square. Now we have to evaluate this. This is t equals b, t equals 0. Okay, upper limit, lower limit, e to the negative s, and this is b, so e to the negative s b, that's the upper limit part, minus lower limit t equals 0, then e raised to 0, that's 1. Okay, now let's take this limit for this here, because that's where we have b. And again, when s is positive, because we already assumed that part, then this will be negative infinity, and e to the negative infinity is 0. Okay, so this is gonna go to 0 when s is positive, and that's the case already anyways. So then this is 5 over s minus, this is gone, so negative, negative, positive, 2 over s is squared. That's the answer, provided s is positive. So the Laplace transform of 2t plus 1 is in fact, for 2 it will be 2 over s squared, plus for 2t, and 5 is 5 over s, provided s is positive. Final.